and we'll probably have a test next Wednesday over sections 1.1 to 1.4. So what are the two things that are left? Pretty simple things. One is the opposite of composition. In other words, suppose you were asked to find f and g so that f of g of x equals, I don't know, the square root of x plus 2. In other words, yesterday we took two small functions like 3x and x minus 4, and we built the composition. Remember doing that yesterday? And what did we do? We said this means g of f of x, so it means plug f into g. So let's see, plug 3x in, so that would be 3x minus 4. Everybody with me? Now we're doing the opposite. We're taking like this big function and we want to break it down into its two pieces. Now that's really easy to do if you just stop and think about it. For example, look at this function. Two things are happening in this function. If you stuck a number in here, it would times by 3 and subtract 4. So you need a function that times by 3 and a function that subtracts 4. All right, so what are the two things that are happening in my problem? There's two things happening to a number here. What happens, Tom?
Square root plus 2.
Exactly. In which order do we do that? If you stuck a number in, like if you stuck 1 in, what would you do to it first? Would you square root it or add 2 to it first?
Add 2.
You'd add 2 to it first. So we need a function that adds 2, we need a function that square roots, and we need to do it in that order. So if I'm building this composition, g is going to be the first thing, right?
Yeah.
What do I need g to do? I need g to be the function that adds 2. So g of x is going to take a number and add 2 to it. What do I need f to do then? F is the second operation in this problem. What do I need it to do? Take the square root of the answer. I need functions that do two things. I need two functions. One of them has to take a number and add 2. The other one needs to square root. If you built that composition using these two functions now, if you built this composition, you would start with g of x, which is x plus 2, and you would plug that into f, which would give you what we wanted, right? Easy. All right, let's try another one. Suppose we wanted to do the same thing, but for this function, we want it to be, how about 5x squared? Now, would you agree that if you put a number into this problem, if you put a number in here, there are two things that are going to happen to it. What are you going to do to it? If you put a number in there, what are you going to do to it? You're going, in which order? Square. You're going to square first, and then you're going to multiply by 5. So remember, the order matters. So the first function has to do the first operation, which you said was squaring, right? This is going to be x squared. Now, what does the second function have to do? Multiply by 5. So the first function takes whatever you give it and squares it. The second function takes whatever you give it and times it by 5. What happens, do you think, if the problem's a little bit bigger than that? What if it's something like 3x squared minus 5? Now, why is this bigger? What's going on here? There's 3 things going on, right? So we have a choice. We can either make 3 functions. I'd have to change my directions because there's only 2 here. But I could make a composition with 3 functions. Or if I'm only gonna use 2, what am I gonna have to do? One function's gonna have to do 2 things, right? Now order matters here. So what is the order? If you put a number in here, what is the order? What happens? We square, times by 3, and subtract 5. So 2 of those things have to be grouped together, and it doesn't matter which 2 as long as you keep them in order. So what might be one option for our first function? If we have to square, times by 3, and subtract 5, what might our first function do? Might be 3x squared. That would take care of squaring and timesing by 3. What do I need my last function to do then? The only thing left is minus 5. So that function would just be x minus 5. It's not 3x squared minus 5. It's just x minus 5. You need a function that subtracts 5. That's what this function does. If you feed it a 3x squared, then you'll get this answer. All right, you try one. I'm going to change the directions now, go a little bit different order, just so you know sometimes we do go in a different order. So let's find f and g so that g of f of x is, let's say 5x squared, no, let's do 5x minus 8 over 6. So see if you can do this. You're going to build 2 functions, f and g. This time, which one comes first? F. We're finding g of f, so f is going to come first. So what would be 2 functions? And there's more than one correct answer. What would be 2 possible functions that would create that problem? See if you can figure that out. You already got it? What's f? 5x minus 8? That's an option. What would g be then? X divided by 6. Because you need to do what 3 operations in this problem? Times by 5, subtract 8, divide by 6. So you chose to have your first function, times by 5, subtract 8. So then the second one, all you had left to do was divide by 6. We could have made our first function just times by 5. That's okay. But then what will the second function have to do? If the first one, all it did was times by 5, the second one's going to have to subtract 8 and divide by 6. That would work too. That's another possible answer. Okay? Then the second thing, the only other thing left, the last idea, big idea in this little section, is the idea of implicit functions. This is a pretty big topic for future calculus students, but it's pretty easy. If we were graphing on our calculator, could we graph that on our calculator? Could we type that in and press graph? We absolutely could, and everything would be perfect. What if I wanted to type this on my calculator? That's going to be a problem, right? Because when you graph things on your calculator, what form does the equation have to be in? Y equals. Not y squared equals, but y equals. So if I were going to graph this on my calculator, the only option that I would have is to do what to it? Square root both sides. And of course that means a plus or minus. So this function actually would get graphed on the calculator as y equals the positive square root of x and y equals the negative square root of x. These are called the implicit functions. Now, here's what's going on. It's very, very simple. First of all, you already know what this looks like. What does that look like? No, this isn't a v. These are absolute values, right? This looks like this, right? What's this look like with that negative out in front of it? It's the same thing that down here. So both of these together would create this sideways parabola. If you did both of these, you'd get that sideways parabola. Is that a function? No. So this is not a function. That's why you can't graph it on your calculator. It's not a function. However, you can break it into two separate pieces that if you look at them individually, are individually they functions. Are they functions individually? Yes. They're called the implicit functions. They're the functions that are implied by this non-function. So you can do that with lots of things. Consider a circle. Is a circle a function? No. But would the top half of a circle be a function? Would the bottom half by itself be a function? So if you took that circle and broke it apart, you could have two little pieces of it that are functions, are graphable on your calculator, and put together would make the whole thing. That's what implicit functions are. You're simply breaking it apart so that you have two pieces, or three, or however many you got, usually two pieces that are functions. Let's look at another example. How about now I want to graph that on my calculator. That's how I always think of it. If I want implicit functions, I just want to get it so I can graph it on my calculator. So you already told me, if I want to graph this on my calculator, what's my equation have to look like? Y equals. So I got to mess around with that until I get it y equals. So is that okay to start that way? Move things around a little bit. Square root both sides. So my implicit functions are the square root of x squared minus 4. And what's the other one? Negative square root of x squared minus 4. This is going to graph the top half of something, and this is going to graph the bottom half of it. And when I put both halves together, it's going to give me whatever this was. Any idea what this was? What this is going to be if I graph it on my calculator? It would be a circle if that were a plus. It's a minus. So it's not a circle. Oh, your second-year algebra teacher would not be happy right now. It's a hyperbola. It's a hyperbola. And when you graph a hyperbola, clearly it's not a function, right? But this would graph this part of it, and this would graph this part of it. So altogether, you get your hyperbola on your calculator. Okay, let's do one more, and then we'll be ready to do some homework questions. Remember, your goal is to put it in your calculator. That's what you want to do. So how would you start?
Put the 4x and 4x on each side, and then square root both sides.
So one of your implicit functions will be the square root of 4x plus 2.
And then the other one will be
Be negative. Nothing tough about this, right?
Yeah.
We can do that. Okay. So anything on your quiz that has you perplexed, you don't think you'll be able to sleep tonight, so you get your quiz back tomorrow, anything there? Or anything in the homework that you have a question about?
Was the integral notation, like, you put it like in the parentheses with the comma?
Yep, with either a closed bracket or an open, or, with either a bracket, if you were including the endpoints, or parentheses if you're not.
Did you do like the and symbol?
I don't know when you would ever use the and symbol, which is the upside down U. But the or symbol links those together. Yeah, if you've got more than one interval, you would say it's this interval or it's this interval, or it's this interval. Use would link that. The upside down and only means intersection, and there weren't any intersections. All right, homework, questions? Something that's bothering you from homework anytime this week? I don't think we've gone over much homework this whole week, so anything at all? Oh, wait a minute, actually, I think I called you last.
Mackenzie, your birthday is definitely coming up.
Yeah.
Could use those points.
Yeah.
What if your birthday was on
Yeah, yeah. All right, any homework, anything from homework? Yes, Katie?
From last night, number 16.
So this is 1.4, number 16. All right, this is a composition, which is where we put them together. So the functions are this and this. And we want to build both compositions, it says. So we'll start with that one. Okay, what is f? F of g of x. Well, if you just say it, you know what it means. F of g of x means take g of x and plug it into f. So g of x is 1 over x minus 1. So I'm going to take that and plug it in here. So I'm going to have 1 over x minus 1 squared minus 1. Because the f function says, give me whatever you're going to give me, I'm going to square it and subtract 1. Well, what we're giving it is g. So we're going to take this, put it right in that box, and this is what it's going to look like when you do that. Now the question said, what's the domain? Well, look at the two pieces of the function. What are the domains here? What's the domain of that? All reals. What's the domain of this one? X can't be 1. When you put it all together, you still have a domain where x can't be 1. And remember the back of the book, this is what it looks like on the number line. That would be your domain. The back of the book is going to write that like this. I said you don't need to do all that, but that's the way it's going to look in the back of the book. Okay? Now the other order, because it said do both, the other order says take f and plug it into g. So that means take this guy and plug him in right there. So you're going to have 1 over x squared minus 1 minus 1, or 1 over x squared minus 2. Now that one is going to have new domain issues, right? What's the domain now? Look at this right down here. What can x not be now? What would make that 0? What'd you say? 1. No, not 1. 1 won't make it 0. What's 1 over 1 squared minus 2? That's not 0. We're good there. 2 would work because you're squaring it. What won't work? The square root of 2 won't work. So your domain here is x can't be plus or minus the square root of 2. Because if you put in the square root of 2, you're going to get 0. When you're trying to figure out what gives you 0, just set it equal to 0 and solve it. Do you see how we get plus or minus root 2? Yeah, that's what gives you 0. So the domain changed in that problem because of the different operations in the function. Okay? Gracie?
This is kind of like an overall question. How do you know like when to stop?
What do you mean when to
Like
stop?
how you like on the first one you stopped like 1 over x
Well,
minus
I probably shouldn't have. I just didn't want to take up class time to simplify that because I figured you can FOIL that. This is the important part. After that, it's just a matter of cleaning it up. So yeah, you probably should FOIL that out. Clean it up. I wouldn't I wouldn't necessarily expect you to get a common denominator, although you could, because once you get this FOILed out, you're still gonna have this -1. So if you wanted to do that, I wouldn't necessarily expect that.
I have like a kind of a basic question, but if your f of x is like x squared minus 1, and then your g of x would be like 5x, would you square the 5 too? And so then you
So
when
if
you
this
plug
were
g, yeah,
5x,
yeah, and then you would plug g, you have
and you're doing f of g,
yeah, would you square 5x?
absolutely you would, because this f of g would be f of 5x, which means you take out the x and put in 5x.
Okay.
So yes, you would. Now, if you went the other way around, if you were plugging this into this, then you wouldn't, you just times them both by 5. All right, anything else you can think of?
Number 9.
In last night's homework? Number 9 says we've graphed a couple of functions. In the first quadrant, one of them is x squared, so I'm gonna go ahead, for this exercise, I'm going to actually plot them. So there's, okay, so this is the 0.11, this is the 0.24. So that's the first one. And then we've graphed y equals 1 over x. This is the 0.2 comma 1/2. So it's gonna look like that. So there are the two functions that we've graphed. Now, we're supposed to be graphing the sum. Lane, you go ahead and go. We're graphing the sum. Now, what that means is, pick an x value. Let's pick 1 as our x value. What is what are the 2 points? Okay, what's the black point? When x is 1, y is? 1. And the green point, when x is 1, y is also 1? So for the sum, when x is 1, what would the y coordinate be if you were adding? 2. So for the sum, we'll plot the point 1 comma 2. I need another color, but I plot the point 1 comma 2. Now let's look at 2. When x is 2, what's the black point? 4. What's the green point? When x is 2, the green point is 1/2. So what would the sum be? At x equals 2, the sum would be 4.5. So we would plot that point. And then, I didn't do my points, but at 3, the black point, I don't need, I guess, a picture of it. At 3, what would the black point be? This was y equals x squared. So at 3, it would be 3 comma 9. And this one was y equals 1 over x. So at 3, that point would be 1/3. So the sum point at 3, the sum would be 3 comma 9 1/3, and so on. And then you just plot these sum points, and that will give you a picture of the sum. So point by point by point, however many of them you want to plot. Okay? If you want to do the difference, you do exactly the same thing, only instead of adding the y coordinates, you would subtract them. We don't generally do a product, but you could, I suppose, if you wanted to do a product too. Same thing. All right. Well, I'll have these graded by tomorrow. We'll go over those, and we'll start reviewing tomorrow. But tonight you've got some more problems, implicit functions, and breaking up your compositions. So you can go ahead and.
Is our test on Wednesday?
I
Is it
think so.
over 1-1 through 1?
4?